Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And I would like to say Selamat Hari Raya to all my friends and to my lecturer Dr. Muhammad Faisal bin Abdul Hamid. Now it is my turn. Muhammad Zulfazi bin Rauhan would like to present you a technique for order preference by similarity to ideal solution, or simply known as Topsis. Okay guys, so what can you expect from these presentations? I would rather to say that before this we have been through for the function tree, the morph matrix, and now we are focusing more on Pugh matrix versus Topsis for product concept generations for multipurpose hanger. So I would like to say that basically we want to see how does Pugh matrix evaluate, and how can we apply the Topsis, and we see the differences between these two tools. Okay, so since this is a presentation which contains the additional contents, so I can say that in the key objective throughout this activity, I have added the fifth objective, which means to analyze and evaluate the conceptual designs using different tools such as Pugh matrix and Topsis. So we're going to see how does these two tools actually plays their roles and give a guidance towards our evaluations, and towards the end how that can guide us to select the best options, which is far from the risk or cost, and very close to the benefits of the good product. Okay guys, before we go into a Topsis or even a Pugh matrix, so this is just a quick recap on the function tree of a multipurpose hanger. As what you can see there, it has been clustered into different 5 functions. The first one, materials, flexibility, aesthetics, compartment, and accessories. And break it down into different sub functions of each of the clusters. You have quite a numbers of the sub functions, and for information, we can't go for each of the sub function because we have to highly choose the most important criteria to be evaluated. Okay guys, so once you have done with the function tree, now we move on to the morph matrix or morphological matrix. What can you see there? There is combinations of different ideas from either 1 up to number 5 in this case, and featuring different functions or even sub functions which you have listed out in the function tree. Okay, as you can see that in the morph matrix, under aesthetic shapes of the sub functions, it has came out with a different 5 ideas, namely triangle, rectangular, round, semisphere, or even multi shapes. So what can you see there? For every sub functions, it promotes versatility or variety of different ideas in different perspective, in different angles. And this is really important because you can come a very unique idea or combinations of idea which can be truly genuine and new, and a very good improvement to the existing product. So this is the best part about the morph matrix, which it combines different ideas and it has tabulated clearly. Okay, towards the end, what can I say? The outcomes of the morph matrix, literally, that the morph matrix enables you or guide you to come up with a different conceptual designs. So in this case, we have concept 1, 2, 3, and 4, and this concept actually comes out with a different ideas, or perhaps it might combine with the same ideas from another concepts. So in this case, we have 4 concepts is being generated and is being reassessed literally towards a different 5 criteria like prices, space saving, portability, aesthetic, and multifunctions. Okay guys, moving on into the first style of the Pugh matrix, we can say that we have 2 important parts here. The first one is the factors or the weightage, and the second one is the scoring systems. Okay, you might ask me why we have to apply the factors or the weightage on the criteria? So simple answers, because we want to represent the significance of the criteria over another criteria. Okay, and what can you see here, that the space saving having the weightage of 0.1 and the hanging capacity is 0.2. Okay, so with the different numbers of the weightage of factors, it shows that the hanging capacity in this case, however, is more significant towards the space saving criteria. Okay, moving on the scoring system, instead of normally in the Pugh matrix we are applying a positive, negative, and or even equal signs. So I would prefer to have a numerical presentation, because it gives a straightforward comparison in terms of numbering from one concept into another concept. Okay, on top of that, I would like to say that the summations or the total sums of the weightage, it must be equal to total score to 1.0. Okay, what are the best part of using the Pugh metric is it allows a normal user, okay, to come up with a straightforward answer, because it doesn't contain any sophisticated or complicated calculations. So in this case, you can say the concept 3 score with a 2.5, followed by the concept 4 with 2.3, and then followed by the concept 2, which is 1.6. So in terms of ranking, we would like to rank them. Once again, the concept 3 will be the first rank, followed by the concept 4, and then concept number 2. Okay, moving on into a second style of the Pugh metric. What can you see here? We have removed the weightages that has been applied before this in each of the criterion, and now we change the concept 1 to be one of the concept to be evaluated, and we choose a magic hanger as a datum. So obviously and literally, I would say that when you do not apply any weightages or factors on each of the criterion, so you can assume that each of the criterion now are having a same significance towards a different style of the concepts. And frankly speaking, that again the concept number 3 would have a higher score with a number of 14s, and then followed by the concept 4, 13, and followed on the third place is followed by the concept number 1 with the total score of 11, and however the concept number 2 become in the ranking of number 4 with a total score of 10 only. Okay guys, I really hope that you are still with me and lending your ears carefully, because now we are moving on into the most complicated part, which is Topsis. So in Topsis we have 8 different steps. Start with the step number 1 up to step number 8. You can't skip any of the step, and you must follow step by step in ascending order. Okay, so in the first step you have to come up with a decision matrix, and in step number 2 you have to quantify the qualitative criteria into a numbers, so then you can make calculations towards them. And then step number 3, non-dimensionalize the attribute value, because this is quite important, because sums of the numbers are not really what can you say in the same fashion. So we would like to have a normalizations of the patterns of the numbers, and follow up by the step number 4, we have to assign the weighted value for the attributes. So this is very close to the one that we have applied before in the Pugh matrix. We applied different weightages or different factors into a different criteria, and followed by next step number 5, we have to establish the ideal, which is the most positive ideal and negative ideal solutions. And step number 6, we have to calculate the separation distance. So in this step we have clustered them into 2 parts. The first one, the separation distance of the positive ideal solution and negative ideal solutions. And step number 7, we have to calculate the closeness rating for each of the concepts. And last but not least, in the step number 8, we might come out with the rank of the concepts. Okay, so zooming in into step number 1, which is creating a decision matrix. So in this case, I would literally say that this is quite equivalent to the one that we had in the Pugh matrix. It's just a matter of tabulating them in a different directions. Before this we have a concept 1 to 4 in terms of vertical order. Now it is being put horizontally, and however we have 1 to 6 different criteria is putting in vertical order. So the criteria that we are choose basically is cost, mechanism, spacious, capacity, portability, and multifunctions. Okay, moving on into a step number 2, quantify the qualitative criteria. So as compared to the Pugh metric, because this is being taken straight away from the Pugh metric as well, so we don't have any problem since we are using a numerical representations, so we don't have to transform a qualitative into quantitative criteria. However, if you have a look in the Pugh metric, we are using a scoring system of number 1, which is represent the lowest, number 2 the medium, and number 3 is the highest. But in the Topsis we have to avoid that because we have come out on the first time, and seems that most of the ranking are not really in what we are expecting for. So we change the scoring system in the Topsis. Instead of 1, 2, and 3, now we are choosing 3, 6, and 9, which means that 3 are representing the lowest, 6 are representing the medium, and however 9 representing the maximum score. Okay, moving on into step number 3, non-dimensionalize the attribute value, or in simple word we can say normalize the numbers. So since in step number 2, thankfully we have been using same versions of a number, which is 3, 6, and 9. So giving you some example, how do we get on the first criteria, which is cost versus concept number 1, with the score of 0.37796. This is simply comes back into a step number 2. When you go into under criteria cost versus concept number 1, you will have a score of 3. So you are taking out this number 3, divide by the square root of 3 squared plus 3 squared plus 6 squared and plus 3 squared, and finally we give you to the number of 0.37796. So in step number 4, we have to assign the weighted value or factors for the attributes. So I would rather to say that this is very important and reflects back to the Pugh metric. We have assigned same numbers of the weightage at cost 0.2, mechanism 0.1, spacious 0.1, capacity 0.2, portability 0.2, and multifunction 0.2. This is exactly the same of the weightage that we have been applying in the Pugh metrics. So when you have a numbers of 0.2 and then multiply it in the step of number 3, that's why we go for the concept number 1, which is 0.37796 multiply of course with the weightage assigned, it will give a number of 0.07559. Guys, moving on to the step number 5, establish the positive ideal and negative ideal solutions. Of course, for the mechanism, spacious, capacity, portability, and multifunctions, we have to bear in mind the highest the value will represent the positive ideal solution, and the lowest the value will represent the negative ideal solutions. However, on the other hand, for the cost items or attributes, is going to be working all other way around. The highest the number will represent the negative, and however the lowest number will represent the positive value. So speaking of that, step number 5 has to be linked up into the step number 4. I have putting in the color which represent the green one represent the positive ideal solution in the step number 4, and then the what we call an amber color will represent a negative ideal solution. So putting the value, tabulated them, and we're going to have the step number 5 as easy as that. Okay, now we are moving into step number 6, calculate the separation distance. And of course we have to use the formula given to calculate the separation distance. Is simply the square root of the summations alternative value minus the positive or negative ideal solution and squared. Alright, so what can we say here? That we have two parts of the separation distance. Either it is moving towards positive ideal solution and the other part is moving towards negative ideal solutions. And of course, for the separation distance, this is being calculated for each of the concept, which is concept number 1, 2, 3 and 4 has to be calculated separately. Okay, so in a simple term, what can I say? That the positive ideal solution and negative ideal solutions, they are really working in the other way around. And from here you can say that the concept number 3 possess the lowest value of the positive ideal solution, means is very close to the positive solutions, and in fact on the negative separation distance it has the highest value. It shows that it is far away from the negative ideal solution. So I can say in step number 6 you're gonna have kind of imagination that the concept number 3 will possess on the first rank. Step number 7, we comes to a calculate the closeness rating, and using the formula where you have a separation distance of the -1 divided by the summations of positive and negative separation distance. So what can you say here? The concept number 3 produce the highest number of 0.7, followed by the concept number 4 0.5, and then concept number 1 0.4, and last but not least concept number 2 0.3. And straight away you comes into step number 8, ranking the alternative based on the closeness rating. You're gonna have the concept number 3 as will be on the first rank, followed by concept number 4, and then concept number 1, and lastly concept number 2. Okay, so frankly one might ask, why does the closeness rating calculations has to be include the negative separation distance as the numerator, and however why does you put the positive ideal solutions as the denominator or the lower part? This is basically about when you have the highest value on the numerator. Let's say when you have the highest value of the negative ideal solutions, it will give an impact to the closeness rating, because it is become the numerator. So the highest the value on the numerator will give the highest score of the closeness rating. However, when you are reducing the value of the positive separation distance, the denominator part, it is going to work on the other way around, and this will increase the number of the closeness rating. So in a simple word, what can I say? For you to have the best selections of the product by using the Topsis, it is basically focusing on the product that comes with the lowest positive ideal solution. It shows that you are very close to the positive ideal solution. So we are aiming for the lowest number of the positive ideal solutions, and at the same time you must have a high number of negative ideal solution, because you want to go far and far away from the ideal solution. So back to the Topsis objective, you are really wanted to have a product which is generate the most ideal positive solutions, which is very close to the ideal solution, and at the same time you are running away from the risk or cost. Okay guys, frankly speaking, by comparison, Pugh evaluation metrics compared to the Topsis evaluations for the multi-purpose hanger, absolutely I can say that concept number 3 will be on the first rank, since on the Pugh or the Topsis are really supported the same result. Okay, and however in comparison we can say that concept number 2 will be on the lowest ranking, because they are producing the lowest score both for Pugh and Topsis. Okay, from a different perspective or angle, what can I say? Pugh metric versus Topsis. Basically the Pugh metrics are comparing one concept number 1, 2, 3 and 4 is being compared to a datum, which is a datum that we are taking out from the list of competitors. In fact, the Topsis, they are not using any datum or any competitors out there, but they are comparing from concept number 1, 2, 3 and 4, between 4 of them, and they are hardly using all the importance formula to come up with the ranking. Okay, last but not least, yes, of course, I can say that Pugh metric and Topsis, both of them are agreed to each other and saying that, concept number 3 will be on the top rank, following by the concept number 4 and then concept number 3, and both of them agreed to say that concept number 2 will be on the last rank. But I would personally literally say that I prefer to choose Topsis over Pugh metric, because the Pugh metric are not give a real indications toward the selections of the concept generations. In comparison to a Topsis, it has a closeness rating, it has a separation distance between positive ideal solution and negative ideal solution. So based on the Topsis itself, I can say again that concept number 3 of course absolutely and definitely will be the best concept generation, because it has the most positive ideal solution, and at the same time it is far away from the negative ideal solution, or something which is become a cause or negative driven towards the selections of it. Again and again, concept number 3 is mainly being chosen and is being proven by the Topsis or even the Pugh matrix is one of the good concept to be working on, because it is cheapest, it's based on the ABS plastic, it has a good features, highly space saving in due to the inclined hanging style, and of course it is very portable due to umbrella design for traveling, so it can cater for the frequent travelers as well. And of course for a sail margin, it has an aesthetic look with the modern design, which embed with the latest design of the hollow and 360 rotations of the pivot, multiple slot for hanging, clippers for small garment. This is going to be the support the multi-functions of the modern multi-purpose hanger. Okay, last but not least, I would say that I'm very grateful to have this opportunity to come up with this subject, because I realized that it really helps me, give me visions how to actually create a good product, select how to select a good product. Actually it start with the come up with the requirement analysis, and we go to the Pareto, and of course we table out the QFD, quality functions of deployments, and then from there we are going to take out the important criteria in terms of what are the customer demands versus the engineering parameters to be looked forwards, and we bring it into the functions tree, and from there we table out and we detail out all the important criteria. And of course in the morph matrix we have come up with different ideas, and then we are able to generate a different concept, and in this case we have generated 4 different concepts for the multi-purpose hanger. And thankfully to the Pugh matrix, is really a straightforward evaluations. In this case we have come out that the concept number 3 is going to be on the top rank, and however concept number 2 is going to be on the last rank, and this evaluation has been reinforced by the Topsis. Of course I would prefer the Topsis because it really make a comprehensive evaluation in terms of positive ideal solutions, in terms of the separation distance itself, and in terms of the closeness rating. So what can I say, that we are looking into a product not with the highest score, but in fact we have to counter check and counterbalance of the positive parts of the product itself, in this case the positive ideal solutions, moving towards the positive ideal solution, which give you the most benefit of it, and this has to be maximized, and at the same time we have to minimize the cost, and the Topsis will be one of the good tools. Thank you very much.